off the southern grouping and mostly within the core field interaction region of the sunspot. If you recall yesterday, a filament on the north snap erupted off to the left. We will confirm that directionality this morning as SOHO now shows the burst heading out to the left as well. That's both C2 and C3 with the CME eruption cloud. Quick look at the solar wind, and we're finally exiting that intensified stream. Geomagnetic conditions now have a whole day without instability under the belt. Let's start the science news at Titan, where a new organic molecule has been discovered in its atmosphere. This is reinvigorating their want to send a probe to Titan, which itself is a mission born of the realization that amidst the methane there is tons of water ice as well. Most of it just locked below the surface. It complements the Starwater Moon discovery we reported yesterday. Up next, looks like a multi-flavor cotton candy exploded. Not far off, really, as it's confirmed that a weird outburst explosion took place within a molecular gas and dust cloud. Quite obviously, it was a nova-like event, triggered by a star born into dusty plasma. And speaking of which, ALMA was able to spot a ton of dust and heavier elements in early galaxies, like the first ones we can see. And they have determined that for being such little baby galaxies in an early universe, they sure managed to look old quickly. The appearance of so much dust implies that the galaxies have been around long enough to have many stars explode. And maybe they just aren't as young as the scientists believe. It's the cosmic timeline problem showing up again. Up next, if you can see how small the zoomed rectangle is in the background picture, you should probably have an idea of just how many stars there are in the central region of the galaxy. But importantly for this study, they've determined that the central region of the Milky Way did not have multiple runs at makeovers between forming and now. There was just one, crushing all previous estimates of the star formation history in our galactic core. Up next, folks, the earthquake prediction world is scrambling, updating their models to include new discoveries. But not me. This paper is one of the newer ones. It's getting a lot of play. Fair weather, the key to their predicting earthquakes, they say. And while they mention a bit of atmospheric electricity, that's about the whole of their useful bounty. They claim to have studied the 213 magnitude 6 and higher earthquakes since 2013. The problem is, there have actually been over 1,000 of those. Heck, just since 2017, there have been over 500. What are they talking about? The one magnitude 8 on their list is the 2014 Chile quake, but they added every foreshock and aftershock to the list, a huge no-no for prediction stats, and in fact, there were 7 magnitude 8 earthquakes during that time. Folks, this paper is totally backwards. Not only are low pressure cells what we look for and notice triggering the release, but that's what the papers on the topic have said thus far. Hey, if you ignore 80% of the data, you can pretty much say whatever you want. Speaking of which, climate science ignores half the sun's input to Earth, overreaches on CO2, and has pitiful certainty marks for cloud and aerosol forcing. And just a few weeks ago, we delivered the bombshell that the drought enhancement shouldn't be as expected as climatologists make us fear. A warmer world is a wetter world, but also one that is easier to tip into cold. The more humidity is not only the reason why I believe the new Valley of the Sun is the place to be in the Western world as the Earth is shifting gears, but it plays directly into the aerosol and cloud uncertainties that have dominated the climate journals this year, and which help cool the planet. We great